Hi everyone. So in this video I'm going to finish the discussion about all the other basic gates. Like in the previous video I have explained the whole thing in the previous video, that is how to use the means how to write the code of AND gate in VHDL. What is the setup and what are the different meanings of the code. I have explained the code thoroughly, line by line, word by word. Okay, so I have already uploaded the link in the description box, so go and check it. First learn the whole thing, how to do the code, what are the meaning of the code, then then after that you can understand that how to do the code and what are the meaning of the code. Because in this video I will not explain the code once again, I will just show the changes that what are the changes you have to do in the AND gate only. Means in this video I will take the AND gate only and I will do some changes in the AND gate, not much more changes, because all NAND will be the same, just the internal structure, means the architecture part will be changed. Otherwise all are will be same, and entity name will be also different. You can keep it same, or I will suggest that change it. Okay, it will be much more better for getting the output or saving the code. So I will show all the changes, that what are the changes we have to do in the AND gate, so that you can get the OR gate also, NAND gate also, NOR gate, XOR, and the NOT gate also. Okay, so at first I will show you how you can change this AND gate and convert it into a 2-input OR gate. Okay, so in this video I will not explain the whole code, I will explain the little portion which are need to be changed for the OR gate. After that we will run the code and check the output also, means the EP wave diagram. Okay, so let's begin. So let's explain the setup part first. Let's go into the left panel where the different type of things are present, like languages and libraries, tools and simulators. This. So first click on the languages and libraries. Then click on the test bench plus design. This arrow part. Here arrow part, click on the VHDL. Okay. Click on the VHDL, because all the code which I shall upload in the YouTube, all the video will be, or means all the code will be in the VHDL format. Okay, so click on the VHDL, leave the libraries part, leave the top entity part for now, because it was different for the AND gate, so it will be different for the OR gate also. Leave the enable V unit. So once again I want to say that go and check the AND gate video, because in there I have explained that what we have to write the entity and which portion we have to write the entity, means all the things I have explained in the previous video. I have also explained the basic details of the EDA Playground also, so go and check it first. Okay, let's move towards the tools and simulators. Click on the tools and simulators, then you can see a arrow button is present. Click on that arrow button, then click on the commercial simulators Aldec Riviera Pro 2023.04. Okay, then don't touch the compiler options, leave it. Whatever value is present in your computer, it will be that only. It can be updated version also, or it can be this 2019 also. Okay, then click on this checkbox. This checkbox must be ticked, that is open EPUF after run, because this is the main important thing which we want to get after completing the program, after running the program. Okay, so this is the important thing, so make sure that this checkbox always have a tick. Okay, so now let's dive into the design part, design.vhd. Now see here, the code is already present. No, in your computer also the code will be already present, because we have already done the AND gate. So in the AND gate, in this AND gate, what changes we have to do so that it becomes the OR gate? What do you think? At first the entity name have to be changed. Now I have told you that entity name is the name in which the code will be safe. So it doesn't matter that whatever you have given the entity gate, you have to change. You can keep it as AND gate also, or you can keep it by your name, any of other names, A, B, C, any type of name, any book name, anything. So for the better understanding, for better understanding for yourself, as well as if this question comes in the practical, you can show your teacher also that this is the OR gate. For that reason, I will suggest that change the entity part. Okay, so now in the entity part, just delete the AND portion and write there OR. So I have changed the entity name as the OR gate. Now the port. In this port, you can change the name also, like A, B, Y, but don't make it so much means messy type of things. Okay, let be as the A, B, and Y only. No need to change this also. So only change the entity name from AND to OR, and then change this AND entity name. Otherwise, error will be occur. Okay, this is one of the important thing. You have to change the entity where you have given the name as OR gate but ending as AND gate. Then how the compiler will decide that whether it is a OR gate and AND gate? So it will give a error. So make sure that the entity name also be changed. If you change the entity name, then make sure end entity name also must be changed. Okay, so I'm making it OR. Now the architecture behavioral of which gate? We are doing OR gate. We have changed the name now, so it will be OR gate. OR gate is begin y equals to, I have explained this part, what is this sign, why we written this in the previous video, AND gate. So I'm telling you, go and check it first. Okay, equals to A and B. We have to change this AND with OR, A or B. Okay, because we are doing OR gate, not AND gate. This is architecture, means I have told in the previous video, in the AND gate only, this is the internal part, we are giving the circuits. So this will be OR gate. Then end architecture behavioral. Okay, so this portion is fully correct. Design.vhd is complete. Now let's move towards the testbench.vhd. Now what are the things we have to change? Let's change the entity name, make it as tb underscore or underscore gate. Then also end entity as tb underscore or underscore gate. Then for the architectural part, we will also change it tb underscore or underscore gate. Then the component part, which we are doing the mapping, means sorry, not the mapping. In this part we are giving the component, that what are the components are present, means the box where different type of data sheet are present. In the data sheet, what are the materials are present in my box, those materials we have to give now. So it have to be changed into OR gate. Okay, I have changed this OR gate. These are done. Signal will be the same, no need to change. Then begin this part, unit under test UUT part. Let's change AND gate to OR gate or underscore gate. Port map will be the same, no need to change anything. Then let's move down. So input will be same, 00011011. Okay, so these things are changed. OR gate. Okay, nothing to be changed here. Let's scroll down. TBA, the inputs are also be same, need to be same, means as 0001. Then wait for 10 nanosecond. Okay, wait process, wait architecture behavior. Okay, all are done. We have changed everything. Now for the running this code, we have to change the top entity name. And what is that? tb underscore, not this AND gate. Okay, not tb AND gate, tb or underscore gate, means the entity name which you have used in the test bench, that name have to be given the top entity for running the code. Okay, so let's click on the run button, which is present in the upper part, like new, run, save. Let's click on the run button. See, the whole output, means the EP wave diagram, is in front of us. Okay, so this is the EP wave. Now see, both are present. Test bench input output is also present, and normal input output is also present, means the design part. So for the input 00, the output is 0. So it is same for the design part also. Test bench part also same, means this is right, design part is also right. Now let's check for the 01. See, for the 01 input, output is 1. Once again, for the AB01 input, output is 1. In the same way, 10. For the 10, output is 1. 1 0 output is 1. 1 1 output is 1. Again in the design part 1 1 output is 1. Now how you can check that, means I want to explain here that how you can check the output, means in the 0 0 0 coming, how you can do the clicking part. So for checking this you have to click, see the cursor where I am clicking. Click on this first part. If you click here, then you can, then this yellow line which is present here, this yellow line will be shift here. Now if you want to check the 0 1, you have to click the cursor here like this. See, this yellow line will be present. In the same way for 1 0, click here. See, this yellow line shift towards this. In the same way for 1 1, click here. Click here. See, 1 1 is present and output is also showing. Okay. So like this you can see the output. So this is all about OR gate. How you can do the OR gate from the AND gate. Now I will show you the next gate. It can be NAND or NOR. I want to say that for doing the NAND gate or NOR gate, we need this code only. Now you can use the OR gate and change it into the NAND, or you can use the AND gate only and you can change the NAND. Because I have shown you all things are same. The only difference or only changes in the entity name and the architectural behavioral part, means Y or B, Y and B like this. So I am taking the AND gate only and I am showing how you can do the NAND gate. Okay. So let's discuss about the NAND gate. How we can do the NAND gate by using this AND gate. Okay. So I have again taken this AND gate. Let's change the name. Entity name I shall keep it as NAND gate. So AND gate is already written. So I have added the extra N. Okay. In the end entity, I will also write it as NAND gate N, and in the Y equals to A NAND B. Okay, done. So design part is complete. Now test bench part, there again entity name I will change and keep it as NAND gate, N entity as NAND gate, behavior as NAND gate, then component NAND gate, then port will be same, and component this will be same, signal will be same, output will be same, UTT it will be NAND gate, then process again same input 00011011, in process everything is correct. Now we will change the top entity name as TB underscore NAND gate underscore NAND underscore gate. Okay, let's run it and check whether it is correct or not. So see, one error has occurred. Now what is the error? That is architecture, compile architecture behavioral of entity AND gate. So it is recognizing that we are doing NAND gate, but we have given the behavior as AND gate. So this is the error, means this is the error. By this the error will be shown to you that this error has been occurred. So see, in the design part I have written this architecture behavioral of AND gate. I didn't change the name into NAND gate. So we have to change this in NAND gate. So let's run again. Simulation has finished. See, the output has occurred. This is the EP wave diagram. So let's see for the 0 0. If you see the NAND gate truth table, then you can get that 0 0 output is 1. See, 1. For the 0 1 it will be 1. Let's see. Yes, 0 1 the output is again 1. 1 0. For the 1 0, see, output is 1. For the 1 1 it will be 0. Output is 0. So NAND gate is correct and it is working smoothly. Now let's move towards the NOR gate. And once again I am telling you, if you want to change this, you can change it by using the NAND gate only, but in this video I will show you by the AND gate only. I will take the AND gate and I will show how you can, what are the changes are needed for doing the NOR gate. Okay, now it's time for the NOR gate. So in the design.vhd I have taken the AND gate only. Okay, I am changing this AND gate only. So let's change the entity name AND gate to NOR gate. Port will be same, again end entity will be changed into AND gate to NOR gate. Then behavioral part will be changed into AND gate to NOR gate, and this y equals to y and b will be changed into y NOR b. So these are all are perfect. Now next move towards the test bench part. Let's change the entity name as NOR gate. Once again the end entity will be NOR gate. Then the behavior part will be NOR gate. Component part will again change into NOR gate. End component all are same. Now the process utility part, this part will also change as NOR gate. Okay, now this port process all will be same. The top entity part will be named as tb underscore nor underscore get. Let's copy and paste. Now let's run. The code is running. See, the output occurs. This is the EP wave diagram. Now if you check the truth table for the NOR gate, for the input 0 0 the output is 1. See, here also output is 1. TBY also 1 means the test bench part, and the design part also giving y as 1. Now second, for 0 1 the output is 0, design part output also is 0. 1 0 1 0 again output is 0, and that was 1 for 1 1 also output must be 0. Let's see for the 1 1 output is 0, test bench output is 0, and the design output is also 0. So NOR gate is also complete. Okay, so now I'm going to show you how you can do the XOR gate. Okay, so for the XOR gate also you can change any code like AND or NAND or NOR, anything, whatever you want you can change that code and convert it into XOR gate. Okay, so for converting into XOR gate I'm using the OR gate only, which will make more faster and easier for converting into the XOR gate. Okay, so at first I'm going to change the entity name, as it is written as OR gate. I will add a X and it is becoming a XOR gate. Okay, XOR gate done. Then A, B in, Y is output. Okay, then end entity also XOR gate 1X XOR gate. Then after that architecture behavioral, here also we have to add 1X, as behavior of whom? Behavior of XOR gate, no, so we have to write as XOR gate. Then again begin y less than equals to A XOR B, we want to do the operation XOR, right? So A XOR B. Then end architecture behavioral. Okay, so design part is complete. Now in the test bench part, again in the entity name we have to change into tb underscore x means XOR gate, then end entity tb underscore XOR gate. Done. Then in the architecture behavior, tb underscore XOR gate. Okay, this is also done. After that in the component also we have to change the name, because we have changed in the design part also, so here also we have to change the name. 1x have to be add, so XOR gate, then a b in out, then y also out. Okay, done. Then signal also complete. Okay, then UUT, unit under test, in the UUT also add 1x XOR gate. Then port map is correct. Process, wait 10 nanosecond, wait, end process, end architecture behavior. Okay, all done. So this is the full code for the XOR gate. Now I'm going to copy this XOR gate tb underscore XOR underscore gate and paste into this top entity. Okay, now I'm clicking on the run button. See, this is the EP wave diagram for the XOR gate. Now again for the XOR gate 0 0 the output is 0. So XOR gate means exclusive OR, right? Exclusive OR. Now for the 0 0 output is 0. See, output is 0. Now for the 0 1 the output must be 1. Let's see. So 0 1 output is 1. In the test bench also, in the design part also it is correct. See, 0 1 output is 1. 1 0 output must be 1. See, 1 0 output 1, 1 0 output 1. Then in the 1 1 the output must be 0. Okay, see, in the 1 1 output is 0, in the 1 1 output is 0. Okay, so this is the XOR gate. So the XOR gate is fully correct. Now let's move towards the XNOR gate. I think you have understand that what are the changes that need to be done with the AND gate so that you can convert it into OR gate as well as NOR gate, XNOR gate. I think you have got it. Okay, now let's move toward the XNOR gate. Okay, again design.vhd, let's change the AND gate as XNOR. Then the end entity name AND gate change into XNOR gate. Then in the behavioral and change into XNOR. And then begin y equals to a and b change into XNOR b. XNOR b. So the design part is complete. Now in the test bench part, let's change the entity name as tb underscore XNOR get. Then again change the end entity as tb underscore XNOR get. Then again behavior part XNOR. Then again component part, change the component part as XNOR. So this is complete. Now change the map part, this UTT means the process part, and get to XNOR. So all will be the same, input output will be same, means not output, I'm sorry, the input will be same, inputs the A and B. Now let's give the entity name tb XNOR get, copy entity pressed. Let's run it. See, simulation has been finished and this is the output for the XNOR gate. If you see the truth table for the XNOR gate, you can see that 0 0 output will be 1. See, 0 0 output 1. For the 0 1 output is 0, 1 0 will be also 0. See, output is 0, and for the 1 1 it will be 1. See, output is 1. So this is the XNOR gate.